Hello and welcome. Today we are completing PortSwigger's lab called URL-based access control can be circumvented. This lab demonstrates a broken access control vulnerability where a front-end access control mechanism can be bypassed, allowing unauthorized users to access the admin panel. To solve the lab, we have to access the admin panel and delete the user Carlos. Let's access the lab and start hacking. First, make sure you are proxying your traffic through Burp Suite. I am using the Community Edition with the built-in browser, and I've turned interception off so we can browse normally. Now, when we try accessing the admin panel, we see this very plain block page that looks different from the normal application responses. Observe that when we right-click and select View Page Source, we only see this access denied text. No HTML structure, no styling, nothing. This is very different from other pages, such as the home page. If we view the source here, we can see a full HTML document with styling, scripts, and layout. This difference is an important clue. When a response looks completely different from the rest of the application, it often means the request was blocked by something in front of the application, such as a reverse proxy, load balancer, or WAF. In other words, the request may never have reached the real backend application. This suggests a workflow like this: client, front-end system, backend app. Of course, we already knew this from the lab description, but now we also know how to spot this kind of functionality. So the question now becomes, what if the front-end blocks /admin, but the backend still trusts something else? This is where routing override headers come into play. These headers are sometimes used internally by reverse proxies and frameworks to rewrite URLs before they reach the application. Depending on the framework or proxy, there are several common routing override headers that might work. These headers might tell the backend, ignore the path in the request line and use this path instead. We are going to use Burp's Intruder to check if any of these headers is trusted by the backend server. First, let's try accessing a path that should not exist. Let's say /some random path. Now go back to Burp. Observe that the get /some random path request returns a 404 not found, which is expected. Let's send this request to Intruder. In Intruder, on a new line, add 2 payload markers to the request by clicking the Add button. Also make sure that the attack type is set to Sniper. This way, each payload we provide next will be placed between the payload markers, so a new request will be sent for each payload. Now, go to the Payloads tab and paste the previous list of headers, which I have linked below, in the Payload Settings section by clicking the Paste button. Next, and this is very important, we will need to add a rule for these payloads. In the Payload Processing section, click the Add button and select Add Suffix. We will add :/ in the suffix field and click OK. Burp will now generate headers like x-original-url: Lastly, make sure that the URL encode these characters option is not checked. Click the Start Attack button. What happens now is pretty interesting. Remember that the frontend sees the request for /some random path. So in theory, every response should return 404 not found. But if we look at the requests, one request stands out. The request containing the x-original URL header returned 200 OK. That means the backend trusted this header and processed the request differently. This is exactly what we are looking for, a response that behaves differently from the others. If we open the response and render it, we can see that it actually loads the home page. So what happened? The frontend saw get some random path and allowed it, but the backend trusted the override header and interpreted the request as get /. This confirms the vulnerability. Now that we know the backend trusts this header, we can exploit it. Let's send a request to repeater. Now change the x-original URL to /admin and send the request. And there we go. We now have access to the admin panel. This works because the frontend only blocks direct requests to /admin, while the backend simply processes whatever path is provided through the trusted header. Since the application relies on the frontend for access control, the backend does not perform its own authorization checks. Now we just need to delete the user Carlos. The delete action requires this endpoint, /admin/delete username equals Carlos. Copy it and add it to the header. send a request. We get this missing parameter username error. This means that although the path is taken from the X original URL header, the query parameters are parsed from the real request URL. To fix this, we move the query string into the request line. Send the request again. We receive a 302 found, which means the action was successful. To confirm that we really deleted Carlos, go back to the admin panel. We see the message user deleted successfully. Also observe that the only other user left to be deleted is winner. You should also see the congratulations, you solved the lab banner. Remember, access control should never rely only on a front-end filter. The backend must enforce authorization checks as well, otherwise attackers can bypass the proxy and access restricted functionality. And that is it for today's video. Thank you for watching and I'll see you in the next one. Bye!